Hello, my name is Ondrej Simecek, and today I would like to present you some of the compounds which were assigned to me. So the first compound I was assigned to was hydrogen sulfide. This is a hydride, and it's a hydride of an element in a p block. It's a sulfur, and we can know that sulfide looks like this. And hydrogen in most of the compounds has the oxidation number of +1. So when we add them up, we get something like this. But we have to balance the charge to get a neutral species. So we have to take two hydrogens, and then we simply end up with the zero charge up here. So this is the final sum formula. And now we will try to develop the Lewis structure. So in H2S, there is a total valence number of electron is 8 because 6 electron comes from the valence shell of the sulfur and 2 times 1 from the hydrogen. So we have 8 valence electrons in total. So the hydrogens will be bind to the sulfur, and in these bonds we have 4 electrons, and we will assign the other electrons to the sulfur. So, and then we can just simply determine that there are no formal charges on the elements, and now we can calculate the oxidation numbers. So sulfur is more electronegative, and therefore it will, we can say, steal the electrons from the hydrogen. So hydrogen will have oxidation state of +1, and sulfur, as it has 8 electrons, it has oxidation state of -2. The next compound was nitric acid. As we can see, the root of the name comes from nitrogen. The suffix "ing" denotes us that it will be the oxo acid with higher oxidation state, and then we can just simply write a sort of general formula for oxo acids. And now we want to just determine the subscript. So hydrogen will have the oxidation state of +1. Oxygen will have the oxidation state of -2. And as it is the higher oxidation state, we will take 5 on the nitrogen. As it has 5 electrons and it can get rid of them. And to get the neutral charge here on the top, we have to take 3 oxygens, because 3 times -3 is -6 plus 1 is -5 plus 5 is 0. And then we can move on to make the sum formula. And before that, we can calculate that in nitric acid we have 24 valence electrons in all the elements, because there are 5 valence electrons in nitrogen, 1 is in hydrogen, and 6 are in those 3 oxygens. So this is 18 plus 5 is 23 plus 1 is 24 valence electrons. And the central atom will be nitrogen. There will be oxygen with hydrogen binded to it, and then we have to bind the other oxygens to it. So it, after all the adjusting of the formal charges, it will look somehow like this, where here we have a formal charge of -1, or 1 minus 1 negative formal charge, and on the nitrogen we will have 1 positive formal charge. And we cannot do a better formula, but we can write a resonance structure, because this electron pair can Oh, sorry, this electron pair can jump here and bind to the nitrogen, while this electron pair will jump on the oxygen. So it will look like this. Of course, there will be the formal charges. So we know the electrons will be delocalized somewhere in between these two oxygens, and then we can determine the formal charges. So here the oxygen will steal the electrons from hydrogen, so it will have +1. Oxygen will steal the electrons even from nitrogen, so it will have -2. Here the oxygen will steal the electrons from the nitrogen as well, so it will have -2 as well. Here -2, and the nitrogen will have oxidation state of 5, and it has lost all of its valence electrons, which were stolen by the surrounding atoms. The next compound is calcium perchlorate tetrahydrate. And this denotes that we will have 4 waters bind to the lattice structure of this ionic compound, and then we can just simply write calcium, which will have a charge of 2 plus or oxidation state of 2 plus as it lies in the second group, and then perchlorate, which comes from perchloric acid. That's because of the suffix ate, which is always in a pair with the suffix -ic in the acid. So it will have the highest possible oxidation state on chlorine, and it will look like that. The highest oxidation state on chlorine is 7, as it also gets rid of all of its electrons in the valence shell. And then we just simply balance the charge, and perchlorate we made by subtracting 1 proton, so the perchlorate group will look like this. It will have 1 minus charge, and then we can just simply add up these two and balance the charges. So as we have here 2 plus, 2 positive charges, and 1 minus charge, we have to take this group 2 times, so it will look like this. So now we have neutral species, and then we just simply add the 4 waters to it. And then we can write the Lewis structures. So in perchlorate we have 32 valence electrons. It was calculated as it was before, so 7 electrons from chlorine, 24 from oxygen, plus 1 which is in the minus charge. So the perchlorate group will look, after adjusting all the formal charges, like this. And here on the oxygen it has its minus charge, and as it has other oxygens, it can have 4 different resonance structures, but I won't draw them now. They are made as they were made by the nitric acid, sorry. And to this compound the calcium will be bind, and here would be the other perchlorate group. So it looks just the same. And to this somehow 4 waters would be attached, but I will draw only 1 water here. So in water, we can find 8 electrons. It will have similar structure to the hydrogen sulfide because oxygen and sulfur are in the same group and they have the same number of valence electrons. Only the bond here will be more polarized because oxygen is more electronegative. So this is the structure of water, and this is the calcium perchlorate. And then we can move on. The next compound was iron 2 hydrogen phosphate. Iron 2 is simple. It is iron with 2 plus charges, and hydrogen phosphate comes from phosphoric acid. Phosphoric acid looks like this. It is H3P, sorry, O4, and as one hydrogen is left in this group, we only subtract 2 protons from it, so it will look like this. And it will have the 2 minus charges as 2 plus charges were subtracted on the protons. And then we want more, simply add them up, and as they do have same charges with an opposite sign, we can write them only like this. So this would be the sum formula of iron 2 hydrogen phosphate, and then we can just draw the structural formula. There are 32 electrons in hydrogen phosphate because 5 of them comes from the phosphorus, 1 comes from the hydrogen, 24 comes from the oxygens, and 2 comes from the 2 minus sign. And the phosphorus will be, of course, in the middle. It will be in the center. And then 1 oxygen will be bind with a double bond. This comes, of course, from the adjusting the formal charges, and there would be these 2 oxygens without anything else with a minus sign, and 1 oxygen with a hydrogen. And when we calculate it, we can get the total number of 32 electrons, and to this the iron 2 plus is binded. So this would be the Lewis structure of iron 2 hydrogen phosphate. And the last compound is complex ion. And in the complex ion we do have a central atom, which is usually transition metal, so in this case silver. And here we have ligands, which can be neutral or charged. In this case they are charged, and they are called, or in the name, they are denoted by chloridol. And for the central atom we have to use the root of the Latin name, so this is argentum. So on the end it will be argentate, but before that we have to write the ligands. And as we have 2 chlorines, we have to give to it this, the prefix D. So we will have dichloridal argentate, which comes from the argentum. Then we have to write the oxidation state, which is 1. And then we can write ion or anion, depends. And how have I calculated the +1 oxidation state? We know that the chloridal ligands do have -1 charge. So as we take 2 of them, we have from the chloridal ligands 2 minus charges, but the whole molecule has only 1 minus charge. So the silver has to have one plus charge to balance the charge to -1. And if we would like to draw the Lewis structure, it would look something like that, just simply two fluorines binding to, okay, I'll write it here, binding to silver, and we are not drawing all the electrons of silver here, because this is just a convention, but the number of valence electrons here are is just right, and yes, it has the total charge of -1. So yeah, and that's simply it. Thank you for your attention. I hope this video was correct and you have enjoyed, and have a nice rest of your day.